capacity 1000. The default is 100. And the aster is so coarse that the points are 100 away or more. At least the subsample aster. Alright. Now 0, 1, 2. Triangulate. Voila. Now we have it. Even because LiDAR is usually not so coarse that you need to restrain the triangle monster so much. And now I'm showing again all the points. Or I'm showing the. And now I have a nice visualization of how the LiDAR points lie above the aster. Now, how high do the points lie above the aster? But there seems to be a systematic offset. And I don't think that this is... I have the feeling the aster is on the ellipsoid. No, I mean, the geoid. Huh? But I mean, look, there's a difference. It's huge. It's about the difference between ellipsoid and geoid. I mean, based on my experience, if I pick point here, and this is a problem that's going to occur. So it's actually good we have this problem. The problem that one data source is on the ellipsoid, the height. That's a mathematical idea which is very useful for computations, but not very useful to know which direction the water flows, because the water doesn't care about the mathematics, it cares about the gravitational field of the Earth. And the Earth looks like a potato, not like an ellipsoid. So that's why we have gravitational fields that are just encoded as geoid rasters. It's like a raster which occasionally gets updated when people improve their model of the Earth's gravitational field, and you need that because that's how the water flows. It doesn't flow on the ellipsoid. I mean, and the two different representations cause trouble all the time because you keep on having data sources in different representations. So if I look at this one and this one, and here it's 29. That's like a 50-meter difference. 50-meter difference, it sounds to me exactly like the ellipsoid geoid difference. I think so. So I think we run into the common problem. I need to convert one of my data sources to the other. But it seems to be sort of 50 meters. And we're talking about the point clouds, which is 200, 300 meters above. So let's just assume that our own points.
What if we put the data, the question that I asked from yesterday, because maybe this button needs a projection, the data as well. I'm looking at the data and it says UP 200, doesn't say what data. So I think, if I remember correctly from the projection, there was a space there for us to be able to put in the data. And perhaps if we put the projection before, maybe.
My software does not care about the datum field at all. I don't use it anywhere. And most commercial software doesn't, because everybody uses geotiff tags, intuitive tags have very poor support for datums. Usually, people have an ASCII string inside the file that tells you what datum it is. And because they forget to update it when they change it, because there's no software that does it automatically when it's just an ASCII string, it's very difficult to trust the vertical data. It's a big problem for LiDAR files that the vertical thing isn't handled very well. So in my software, you can set it to something. Some customers, they say to me, my customer wants the vertical data to be set to something. So that's why I provide it. They want it. But I don't know many software that actually uses that for something, because most of the time you can't trust it anyway. Most of the time we don't even trust what we think it is. So it doesn't really impact very much this exercise, because the difference in datum, I think here, oh look, there's a nice way actually to see how big the difference actually is. And this concept is called drop lines. There's a menu entry, it's called drop lines. And it's going to hang a line from every point, and you can see how long this line will be. Let's try 20 meters. Now we have a 20-meter line hanging from every point. Actually, let's only look at the points of light line 1. Yeah. So no drop line comes through the surface. That means we are higher than 20 meters. Let's try drop lines 50 meters. Oh, then we can poke it through. But barely, not everywhere. So I think 50 meters is a pretty safe guess. I think our data is 50 meters higher than the Aster, plus minus a little bit. However, our clouds are way higher than that. I mean, way higher than that. Yeah?
Why don't you just get the control points and make estimated surface and use that to subtract the clouds?
We could do that,
Yeah.
but
I think it's somehow faster and better, since there's a little difference between the LiDAR points and the control points. And if you estimate a surface in that, maybe you can subtract hundreds of meters above, so that you can remove the clouds.
so that's an interesting suggestion. Instead of using the Aster,
Yeah.
we could use the ground points. The only problem with the ground points is usually you don't have a dense enough spacing of ground points. Because if you don't have a ground points on the peak of every mountain, then the mountains will be cut off in your ground point surface. And that means when you do a cut off based on height above the surface, if you have a very high peak, that peak is also gone. And I think the Aster is a bit more, distributed. And it's a good, actually we run into this problem, because you will run into this problem. So in a way, it's kind of educational to see the problem with using the Aster DTM. Make sure they're in the same, I said at the beginning, make sure they're in the same. And that's why I visually looked at it. And visually looking at it helped me identify the problem before I cut off the mountains, because I make wrong assumptions. So I know now that my own points are 50 meters in this area, more or less above. What I should really do, I should tell my assistant to go and get me the Aster in ellipsoidal heights, because my data is in ellipsoidal heights, because when it comes from Optec, out of LMS Optec, it is still in ellipsoidal heights. And I think I like to keep my data in ellipsoidal heights as long as possible. And only when you just about to create the DTMs, then go into autometric heights. Because the geoid line is mathematically well defined. It's WGS84, period. With the geoid, they have they update the geoid, you need a which geoid, and you need to look for the files. It's easy to go from WGS to geoid, because if you need to work on a geoid, you will have that file. But going back, there are often more ways You need to know which geo to go back to WPS. Anyway, so we will just say our height is already 50 meters above. So we need to be a bit careful with cutting it off. So let's remove Masbate ASCII from here because we need to finish in a few minutes. Oh, this is fast, so we have another 7 minutes. Glad it's fast. Until 10:30 we have this morning. So I'm removing this from these. I'm disabling the pick area. And now I say the output goes into my denoised files. Sample data, Masbate, 2 kilometer strips, declouded. And now I say drop points with the height above. So you can do all kind of cool stuff. You can classify points and so on. But you can also drop points. Now we have to think, which points am I going to drop? So my own points are 50 meters above, plus minus. Let's be quite generous, you know. And then there are vegetation and so on top of it. 50 meter. Let's add another 100 meter. 150 meter. If the points are higher than 150 meters, then I think they're going to be clouds. Maybe I should use 200 meters. Well, that's something you could, you know, when you have more time, do a few iterations, do a sanity check. You could also say drop all the points below and then afterwards look at them, make sure you only cut out the, when you want to have only the clouds. But here we say drop all the points that are 150 meters or higher. And I think this will lead us only with the cloud, this will delete all the cloud points. And now I can run this, of course, on 4 cores. Now let's look at that command line. That's going to be a completely new and super exciting command line that we're going to run just before lunch. And I hope we don't screw it up so we can stop on time. So I use the Masbate 2 kilometer to 4 strips. There shouldn't be any more that aster in there. I deleted it. I'm running on 4 cores. I'm using external ground points, minus ground points. And that is the Masbate aster in LATS format. No, I'm dropping any point that is 150 meter or higher above this. I'm just wondering, do I need a concavity or not here? Because I have such wide space points. Do you ever use a concavity in last height? No? Well, good that you were the developer who can just have a look at the source code. So this is the holy grail here. This is the source code of LAStools. Concavity here. No, I don't use concavity anywhere. That means I'm not deleting anything. Okay. Good. I just want to make sure that there's no unsuspected result. The output directory, and it should be LAZ format. Start. So what it will do, it will load the aster, cut out a generous piece of part of it that is just for this strip, compute the tin, compute the point, either every point above that tin, and then if it's a higher than 150, it's going to kick out that point. Seems to be done. Now I have my scripts here. Let me look at them. So I just look at them now with double click because I don't have enough time to start last view again. The clouds are gone. No more clouds. Of course, the shadow of the cloud is now a hole in the data. And that's why you don't want to fly when there are clouds, because the cloud will make a shadow from the viewpoint of the laser, and you don't get data there. But, you know, that's... I'm looking at this one here. Yeah, the clouds are history. Looking at the next one. No more clouds. And all the, it's important to look at all the highest points, you know, and look, are the mountain tops cut up also? But it doesn't look like it. The highest terrain points seem to be all still there. But no more clouds. So, now you know, if you don't like the weather, how to get rid of clouds, at least in the digital world. And I believe that's all the time we have today, because I was told after to stop at 10:30, then we're going to have super early lunch, and then we're going to sit in the bus and go enjoy crazy Manila traffic for 2 hours. Okay, so that's actually, I mean, depending on how cloudy the islands are where you're from, that is a very important task to robustly remove these clouds. Because if you don't, and you start ground classification, the clouds become ground. And that has to do with how this algorithm works. If I have a huge cloud in here, it's like an IKEA, or you know, if I have a huge cloud in here, it will make that cloud become part of the ground. Because if it doesn't penetrate the cloud, as soon as the light penetrates the cloud, it's fine. But if the cloud is floating high and there's no point below it, then the algorithm thinks, wow, a really tall mountain. Okay. Was that clear? How to use the aster? Or, I mean, if you want to send out surveyors, you know, it's what you could do with the ground points. You could use the ground points to check your aster, for example. Find out the differences. How high is it from 50 meters, 60 meters, you know, and then have a better estimate. But or you could use the ground points to, instead of the geoid, if you don't have a geoid, to put it on the same place as where the other control points in WGS coordinates or on the geoid usually.
When you're using the GPS,
Yeah. That's why I think, I mean, keeping everything in WGS is a good idea, I think, because it's mathematically unique defined. And the geoids, which geoid did you use? Geoid of 72, of 84, of 86, 99. Eventually they're going to come up with a new one. And since these data are meant to last many years, geoids change. And since they're poorly documented, which geoid it is, because the file formats don't have good documentation for geoids, having it in WGS as long as possible is pretty seamless to do. WGS is one of the few things that's very well documented. Alright. Why did we not denoise it? Because the cloud looks like a gigantic top of a tree. The points are very close to each other in the clouds. And last noise only works for isolated points that are far away from each other. It looks like a structure. The cloud. It is a structure. It is 1,000 points very close by. And last noise cannot remove the 1,000 points very close by. Well, it could, but then you remove many other signals that I don't know. Maybe there are some settings that will work. For example, I use a step size of 100 by 100 by 50 by 50 meters. And if I have